Hi everyone, I'm Alby Eldho from Cardiff Metropolitan University and I'm studying MSc Data Science. Today I will present my project on AI-based prediction model for customer churn in a subscription-based service. This study focuses on identifying customers likely to leave and help business improve their retentions. Introduction. Subscription-based models are part of our day-to-day lives. These services are widely used today in industries like telecom and streaming. However, one of the biggest challenges in customer churn, which directly impact a business, is their revenue and growth. Aim and objective. The aim of this project is to develop an AI-based model to predict the customer churn. The objective includes building a reliable model, comparing their performance, and identifying key factors influencing a churn. Research questions. This study answers four key questions. Which model are suitable? Which performs best? What factors influence the churn? And how the prediction outcome can benefit an organization? Literature review and gap. The literature review analyzed the research conducted in the field to identify the best suitable model as well as the potential gap in the existing research. Previous research faced issues like small data set, poor generalization, and imbalance. The study addresses these gaps by using larger dataset and focusing on multiple evaluation metrics beyond the accuracy. Research methodology. The research follows a positive philosophy and a detective approach. It uses modeling and testing strategy with secondary data, including processing, EDA, modeling, and evaluation. Data collection and analysis. Data was collected from UC Irwin repository, and this project uses Python and Jupyter Notebook. Data cleaning and processing were done to resolve any data quality issues within the raw data collected. Exploratory data analysis were performed to understand the underlying patterns within the data. Machine learning models developed and trained are done with the processed data. Later, testing and evaluation of the models were done. Evaluation and result. As said, the project uses Python and Jupyter Notebook. Two datasets were analyzed, that telecom churn and streaming churn. Each data was processed separately and models are developed and evaluated. Moving on to telecom churn EDA. Exploratory data analysis showed churn distribution and feature patterns. I have shown bar chart and a pie chart for churn distribution and count. On the right-hand side, it's the feature distribution for telecom churn. Visualizations like box plots and heat maps helped understanding relationship between the variables. Telecom modeling and evaluation. Seven models were tested, including random foresting, KNN, and logistic regression. Random forest performed the best based on accuracy, precision, recall, F1 score, and ROC AUC. F1 score was important due to class imbalance. ROC AUC confirmed model reliability, and confusion metrics helped evaluate prediction accuracy in terms of errors. For the best model, feature important is plotted to identify the most important features that influence the prediction performance of the model. The top features influencing a churn were complaints, seconds of use, customer status, subscription length, and frequency of the use. Moving on to streaming churn modeling and evaluation. Same model, same method was used to streaming churn. For streaming data, gradient boosting performed the best. Techniques like smooth and hyperparameter tunings were applied, but baseline models performed the better. This is the baseline model and smooth result, which shows the gradient boosting worked the best for streaming data. The key features included maximum inactivity days, daily minutes, support calls, and email subscription status. Telecom versus streaming churn prediction. Comparison. Comparing both datasets, random forest telecom model outperformed the gradient boost streaming model across the evaluation metrics. Prediction GUI for telecom and streaming. A user-friendly GUI was developed with separate tabs for telecom and streaming data. It predicts churn and provides probability scores. Conclusion. In conclusion, 7 models were identified. Random forest and gradient boost performed best. The best AI model for predicting customer churn for telecom churn data set is random forest, and for streaming churn data set is gradient boost. When both are compared, random forest modeling for the telecom churn prediction performed better. Key churn factors include complaints, usage, and inactivity status. Limitations and recommendations. Limitations include limited data sets and generalization issues. Future work should use larger data sets exploring data, learning, and applying time series analysis. These are my reference for this project. Thank you and have a nice day.